Hi everyone, so the next topic is logical operations. So the R can judge if some statement is true or false. Okay, so example, suppose x is 5 and y is 6. Is x is equal to 5 true or false? That can be done by x double equal 5. So this means is x is equal to 5 true? And actually this is true because we defined x as 5. But if x double equals 4, since x is not equal to 4, the answer is false. We can do the same, a similar thing for x is larger than 5 or x is smaller than 5. X is larger than 5 is false, so it returns false. X is smaller than 5, it returns false. X is larger or equal to 5, this should be true. So true. X is smaller than or equal to, then true. And true and false. So these are logical values. So we have studied the numeric values, character values, and factor values. But here, the logical values. So logical values are basically either true or false. And true is regarded as 1, and false is regarded as false. For example, this is true, so this should be 1. So we add this to 1, then this becomes 2. And this logical vector can be applied, logical operation can be applied for vectors. Whether the x and y are larger than 6 and 5, so this means x is larger than 6 and y is larger than 5. So R judges these two statements. The first one is false, the second one is true, since x is 5 and y is 6. And actually, it returns false and true. So we can do multiple logical operations at once. Yeah, so the next topic is AND, OR, and XOR, and NOT. Oh, before that, we will have to discuss another one. So X is not equal to something, and NOT is represented by exclamation mark. Then x is 5, so actually it's not equal to 4. So this output should be true, and actually true. And the next AND, OR, XOR, and the NOT. So if we have two statements, we can think about AND and OR. The first, the AND. X is equal to 5, and y is equal to 6. Since x is 5 and y is 6, then this should be true because both statements are true. So AND is the operation that both are true, then it returns true. If one of these are false, then it returns false. Both are false, also false. So that is the AND. So AND, the output is true. So the first one is true, second one is true, so this is also true. And OR. OR is actually expressed by this, the vertical line. So vertical line is actually the, I think the most right key on the line of the QWERT on the keyboard. So X just next to brace. And yeah, OR. So for example, X is equal to 5 and Y is equal to 4, for example. And X is equal to 5 is true, and Y is equal to 4 is false. But anyway, so first of one of these statements, at least one of these statements, statement is true, then OR operator returns true. So this is true. If both are incorrect, this is false. So if X is equal to 3, Y is equal to 4, then both statements are false. X is 5 and Y is 6. So this returns false. Of course, both are satisfied. That's fine. 5 and 6, still fine. True. And XOR. XOR is similar to OR, but this means that exactly one of the two condition is true. So exactly one of the two conditions are true. So X is equal to 5, Y is equal to 6, then both are true, so actually it returns false. But if only one of these are true, then it returns true. And both are false, of course, it's false. And next, not. So remember that the X exclamation equal 4. So this is the logical operation to judge X is not equal to 4, whether or not X is not equal to 4. So the same thing here. So X is equal to 5. This is true. If we put exclamation mark, then this is the opposite. So X is equal to 5 is true. So not X is equal to 5 is false. So false. X is equal to 6 is false, so not true. So these are basic logical operations. So and, or, and XOR, and not. And sometimes we have the double and. X is equal to 1 and the Y is equal to 6, false. So this works almost in the same way as AND, but computationally it's slightly different. My understanding is that the first statement, so AND operator returns true only if these statements are both true. But actually this stops. If you use double AND, the operation stops if the one of the statement is false, at least not true, then we stop. So computationally it's different, but logically it's almost the same thing. So you can just simply use the single AND and a single OR. So OR has similar thing. And for vectors only, the single AND and single OR that work. So that is just, there is no logical reason behind it, but R works in that way. So the single AND and single OR are usually convenient, except there are some specific computational reasons to use the double AND and double OR. So those are logical operations. Next, the conditioning. So sometimes we want to confine the data set. For example, the data sets includes both male and female, but we want to extract the female only. So we can do that job by using logical operations. So remember that earlier we defined the data frame D. So we have 5 patients in the data frame D. The 1, 2, 3, 4, 5, 3 male, 2 females, and the blood pressure for all 5 people. And we want to confine this data set into female. So we want to define another data frame which consists of the second and fourth rows only. So how to do that? So we define a vector, the COND, condition. We focus on the gender vector of D, and we want to see if this is equal to female. So this is F. Then it returns false, true, false, true, false. Because the male, the M is not F, and F is F. So false, true, false, true, false. So using this condition, COND vector, we can extract only the female rows. So that can be done by D COND. So in the past, we typed the C24 to extract the second observations and false observations. But here is another way. You can specify the logical vector whose length is the same as the number of rows in this data frame. Then actually we can extract the rows which satisfies the condition true. So the COND bracket is returns this output. So it only includes the female. So this is how to do conditioning. So this is extremely useful when you are handling data sets.